Hello. Today we are going to learn network layer in networking. In Module 4, we have these topics: IP addressing and subnetting, routing and forwarding, IPv4 and IPv6. IP addressing is a fundamental aspect of networking that enables devices to communicate with each other on a network. An IP address is a unique identifier assigned to each device on a network, and it consists of a series of numbers separated by periods. There are two versions of IP addressing, IPv4 and IPv6. IPv4 addresses are 32 bits long and are represented in decimal format, while IPv6 addresses are 128 bits long and are represented in hexadecimal format. IP addressing also involves the concept of subnetting, which is the process of dividing a larger network into smaller subnetworks or subnets. Subnetting is done by borrowing bits from the host portion of the IP address to create a subnet mask, which is used to determine the network and host portions of the IP address. For example, in a Class C network with the IP address 192.168.0.0, the default subnet mask is .255.255.255.0. This means that the first 3 octets of the IP address represent the network portion, while the last octet represents the host portion. By borrowing bits from the host portion of the IP address, we can create subnets with different network and host portions. To subnet a network, we first determine the number of subnets and hosts per subnet that we require. We then convert these values to binary and determine the number of bits required to represent each value. We then borrow that number of bits from the host portion of the IP address to create the subnet mask. For example, if we want to create 4 subnets from the Class C network with the IP address 192.168.0.0, we need to borrow 2 bits from the host portion of the IP address. This creates a subnet mask of 255.255.255.192, which means that the first 3 octets represent the network portion, while the last octet is split into 2 portions, the subnet portion the first 2 bits and the host portion the remaining 6 bits. This allows us to create 4 subnets with 62 hosts each, as the subnet portion can represent 4 different values O3, while the host portion can represent 64 different values O63. The subnets would have the IP addresses 192.168.0.026, 192.168.0.6426, 192.168.0.12826, and 192.168.0.19-26. Routing and forwarding. Routing and forwarding are 2 important concepts in networking that are essential for the proper functioning of a network. Routing refers to the process of selecting the best path for network traffic to travel from one network to another. This is typically done by routers, which are network devices that use routing protocols to exchange information about network topology and make decisions about the best path for network traffic. Routing protocols use metrics such as hop count, bandwidth, delay, and reliability to determine the best path for network traffic. The most commonly used routing protocol on the Internet is the Border Gateway Protocol (BGP), which is used by Internet Service Providers (ISPs) to exchange routing information and direct traffic between networks. Forwarding, on the other hand, refers to the actual process of moving network traffic from one interface to another within a network device. This is done by examining the destination IP address in the packet header and looking up the next hop in the routing table. The packet is then sent out the appropriate interface to the next hop device. Forwarding decisions are typically made based on the routing information learned by the router through routing protocols or by static configuration. Forwarding can occur at various levels of the network stack, including at the physical, data link, network, transport, and application layers. IPv4 and IPv6 are two different versions of the Internet Protocol IP, which is used to identify and communicate with devices on a network. IPv4, or Internet Protocol version 4, is the most widely used version of IP today. It uses a 32-bit address scheme and supports approximately 4.3 billion unique addresses. However, due to the explosive growth of the Internet and the increasing number of devices being connected to it, IPv4 addresses are becoming scarce. IPv6, or Internet Protocol version 6, was developed to address the limitations of IPv4 and provide a larger address space. IPv6 uses a 128-bit address scheme, which supports approximately 340 undecillion unique addresses, ensuring that there will be enough addresses for the foreseeable future. In addition to providing a larger address space, IPv6 also includes features such as improved security and enhanced support for mobile devices. However, due to the widespread use of IPv4 and the need to support both IPv4 and IPv6, many networks today use a dual-stack approach, where devices are configured with both an IPv4 and an IPv6 address. Overall, IPv6 is gradually replacing IPv4 as the preferred protocol for the Internet and other networks, but the transition is expected to take several years. Thank you for watching us. Stay tuned for next video.